Welcome everyone to this virtual space. Professor Dempski, I, Professor Picon, and our research team will be sharing our research project about designing and implementing the extended reality tools in chemistry laboratories at WPI. Our research group's goal is to enhance learning outcomes through addressing the challenges that lab instructor and students face when learning chemistry in the CH1010 laboratory, which is the first lab course of the CH10 series. Several scholars and our research team has shown that implementing technology enhances learning outcomes. For example, our research group designed and deployed AR and VR tools to support teachers and students in learning safety rules and laboratory setups in both college and high school settings. We proposed the XR iterative development model to build pedagogical tools. This model involves 3 iterative cycles. We'll be sharing with you our work related to the first iterative cycle, specifically the discovering, defining, and developing stages of 2 XR tools. In order to develop the 360 Lab Tour and co-molecular apps, we began our first iterative cycle by discovering and defining teaching and learning challenges and ways of using these tools in the lab. We conducted a focus group with 3 CBC faculty who teach CH10 laboratory, and our analysis revealed that the student understanding of lab safety rules and disciplinary concepts such as polarity is one of the major challenges in the lab. The lab instructors thought that the 360 Lab Tour and co-molecular apps can be deployed in the safety training and discussion sessions respectively. In what follows, Dashiell Elliott and Claire Lee will be sharing the process of developing these tools.
The 360 Lab Tour app is an extension on Matterport virtual tours. Matterport is most commonly used in the real estate industry, but similar technology can be seen in Google Street View. The goal of the app is to give students the ability to learn critical safety information in an environment that closely matches the one they'll be working in. We utilize tags embedded in 3D space that contain text and images with safety information relating to important objects. One specific focus was in waste information, since that was identified as missing from the current safety training in our focus group. Once students feel ready, they take the in-app quiz, which has them find certain objects around the lab without the help of tags to guide them. One potential plan for the future of the app is to improve pre-lab readings and work by taking experiment setup scans. This app was made with Next.js and the Matterport SDK and API.
Co-molecular is a web-based AR application designed to let users visualize molecules as interactive 3D models, which can be used cross-platform on laptop and mobile devices. The previous focus group study with lab instructors revealed that students often struggle to fully understand molecule polarity concepts. To address this, we designed the app that allows users to easily visualize bond and molecule dipoles, with key polarity influencing areas highlighted for clarity. The app will be introduced to teaching assistants and students as a supplementary tool for the discussion module in CH1010 lab course.
Our next step is to assess the effectiveness of the 360 Lab Tour app. To do this, we plan to study how this tool supports students in being engaged and motivated, as well as assess whether they understand lab safety rules and molecular polarity. The data sources will be students' exploration of the apps, quizzes, surveys, class observations, and interviews with students and TAs. We anticipate that the 360 Lab Tour and co-molecular AR apps will be part of a repertoire of pedagogical tools that Chem 1010 lab instructors can use to enhance learning outcomes. We also expect to use this across the chemistry and biochemistry curriculum. Finally, we are currently working with EHS to find ways of implementing these tools across WPI's campus. To disseminate our work, we plan to present our findings in national and international conferences, and we are in the midst of preparing a manuscript for the Journal of Chemical Education. Finally, we'd like to thank a variety of individuals for their support. This includes WPI, the Morgan Teaching and Learning Center, the undergraduate students who participated in this project, the Dean of Undergraduate Students, as well as Teaching Innovation Grants, our home department, participant faculty in this study, as well as Claire, Max Chen, and Dashiell, who have been integral in the development of this program.